my phone because it still works. Last year when I ran the panel, literally my iPad with all my notes on them broke about there, like on my way up to up here. So, welcome everyone. Welcome to the Rust and Safety panel. Welcome Jonas, Rolland, Daniel. Jonas I've had described at some point as like the jack of all trades of safety at Vektor. Maybe you want to introduce yourself after you talk again.
Yeah, no, it's all right. Yeah, I'm with Vektor now for more than 11 years. And yeah, at the embedded department, basically working on safety and redesigning our development processes and taking care that we can sell our products into safety-related systems in the automotive industry. I think that's fair.
Well, Rolland, I've also met around the industry multiple times at multiple employers. At ESOL, the Trust and Soft, maybe.
Yeah, so Rolland Dudemaine, I've been doing operating systems for 25 years and working with all industries. Actually, been working with Vektor a lot in the past years as well. And well, I fell in love with formal verification, which is just a corner case of what Rust actually brings forward.
Daniel, over to you.
Hello again, Daniel. Gosh, I've been in open source for decades and decades, but it's about 10 years now that I've been looking at any kind of safety stuff. I'm, quite importantly, not formally trained in any of this, so I'm trying to bring a little bit of an alternative perspective.
So Daniel is a long year Rust contributor.
Sorry, yeah, I used to maintain Rust up, so
yeah,
you know that.
It's not a big thing. Like he built the installer for it that you use every day. So the first question I have is like we use the word safety so casually all the time, and one thing I observe is that everyone has a little bit of a different perspective. So if I could get from you like a very quick like what does safety mean to you, and what's the core of how you personally are thinking about particularly functional safety?
Shall I start? Okay. Again, I'm not formally in this, so for me, safety is about making sure that the software that we are working with is not going to cause problems in the domain that it's deployed in. I get told to talk about things like loss of life, loss of function, all of those things. But for me, it's much more about the behavior in deployment. But we also look at safety very much from the perspective of the tooling that is giving us the evidence around that. That's perhaps somewhere more that I would be interested.
Yeah. So there's an interesting parallel always between safety and security. I like to define safety in demonstrating that everything works as intended. There's a famous saying. It's basically say what you do what you say, show what you've done. And then security is just the extension of it, that you demonstrate that it works and it does nothing else. You know, the tiny additional bit that's horrible to prove. But safety is mainly works as intended.
Agreed. I'm working for a software development company, so right. So for me, it's about faults in software, what happens with them, and it's actually about a bit more about understanding what your software is actually doing and what it's not supposed to be doing. So I think there's also this kind of aspect, like out of bounds successes. There's nothing that will be specified. Yeah, write a few bytes more. So it's about understanding that it's exactly doing what it's supposed to do, but also not something that it's not intended to be doing. And something that Daniel said is that it's not that you're sure that you understood what it's doing, but that you'll be able to show to others that this is what it's doing, and that you have some kind of evidence, even for some 15 years in future, that you know what you've done there.
So do you also take it as a communication effort in that sense? Because
yes, absolutely. What else should I say?
That was great communication.
If you look into the big safety problems, it's typically not a single cause, and typically in the many cases not technical. but rather multiple points of failures and typically communication failures involved. Yeah.
Yes, thank you. So next question I have is like, we've seen a lot of reasons for Rust, and there's classic reasons that are being thrown around, memory safety and all of these things. And the question I have to you is like, what is an advantage Rust brings to safety that might not be immediately apparent? Like something that you have looked at and you're like, oh, this is really interesting, but not a lot of people are talking about it.
And I think it has been mentioned a couple of times, but that sort of fearless approach to software engineering, the fact that we can look at a piece of code that needs to run on a microcontroller that's attached to something we're monitoring, or tooling that's doing analysis, or tooling that's running to test a property, or tooling that's actually in the safety chain. All of that can be written in Rust, and we can be confident that what we're writing is something that we're going to understand and we're going to be able to take forward.
I'd like to give an example. In last year, I was at the HIS conference in UK, where most of the attendees are actually in the aerospace domain. And in the aerospace domain, you see C code because of that's what I know, and also Ada, because Ada is a very robust language. And it was interesting to see that there was light in the eyes of many engineers and many managers, because finally we can get rid of Ada. Maybe Rust is a solution. So, of course, they will take a lot of time to move, because they need to demonstrate that, yes, Rust to the letter can actually move forward in their domain. But it was interesting that, well, Rust seems to check all the things that they find interesting in a robust area, in a robust domain.
One thing I recently read, and that is something that I was not thinking about before that, is that the type system, I briefly scratched that in my presentation, but the type system of Rust enables formal verification. And like, if you think about pharmacy, no one wants to do that, right? But the type system now allows us to do much more formal verification, and much better allows us to understand what actually the software is supposed to do.
Interesting. I've seen Rust being referred to at a formal verification conference as morally pure, like in the sense of a pure programming language. And that I found that a very interesting statement, because purity is a very strictly defined term, and someone just using like, it's morally pure. It is like, it's 99% there. From someone who does formal verification was an interesting thing to hear. The other way around is, what is a gap that you see in Rust that is not immediately apparent, but actually you meet in daily work, like something that's still a roadblock?
I'd say the biggest problem that we've had with trying to advance the use of Rust in our safety approaches is simply education. It's that the people that we have that have decades of experience working in these areas haven't yet got to Rust. And so when we say, okay, we have this piece of software, it's written in Rust, it's part of the safety chain, their immediate response is often, can we please replace that with some C so that I can understand it? Which is sad. But that's where we are. So I think there's a lot of education still that needs to happen, whether that's just encouraging people to do that training or making new training that is specifically focused at encouraging these people to pick it up.
So that's true. At the same time, it seems like people who have a weak model of object-oriented and some knowledge of C can convert quite easily. And there are public studies you can find where the agreement seems to be that after a few weeks they can read, and after a few months they can actually write. And doesn't mean they're completely productive, but they can write, which is nice. I think one of the things that is missing is complete control on the software. By that I mean, in C you had to redo so many things yourself that it's not uncommon in the industrial projects that you actually redo everything. And in Rust, at least on desktop Rust, you will pull things and dependencies from crates.io And actually, that's fine in some cases, and that's not in the safety domain necessarily. Or you have to take control of what you're doing, and so there's a topic of improvement there.
Yeah, because like this kind of supply chain thing you have to do with all languages, right? But I think I scratched that also in my presentation, right? I still think if you want to tell the complete story, and like safety is always about storytelling, identifying what kind of arguments do I need and which arguments do I take to argue that my software system, whatever I built, is actually safe. And yes, very often we rely still on code coverage, and that there's something missing still. And on some other parts of the ecosystem, we have some smaller gaps. But I think this is a gap that we can fill within the next 2 years.
What's your impression of those gaps? Are they in any way like, I mean, you were saying can't be filled in 2 years. I mean, education is a gap that, I mean, the REST community also gets good feedback on actually being quite aggressive in education. There's an open book out there that's been there since day one and so on and so forth. And there's a training initiative by the REST Foundation. So even more coal into the fire, sounds like it at some of the places. Okay, that's interesting. And my final question is like, what is the thing that people, okay, you want to say something?
I was just going to say that, at least from what I've been seeing, the perceived gap is not that there's no education materials. It's about having that stuff that's focused on enabling people who are long-term experienced on assessing and thinking about the safety in C to be able to migrate to thinking about that in Rust.
I mean, I'm always up for more education, so.
On the education topic, this weekend, because they do stuff in the weekend in China, at the Rust China event, there was a panel of a number of professors who actually said, for the first time, we think we can actually switch away from Java to teach students a new language. And they were stuck with Java for object-oriented, and it seems like finally they can move to something else that at the same time has industrial value, because people are searching for engineers there in Rust. And
I so love this because I studied at a time where everyone at universities was so happy that they could finally switch to Java as the one language and be done with it for the next 20 years. So well, the final question I have is, what is a complete non-issue that people talk about far too much in Rust? I would be really interested.
Go ahead. You first.
Great, put me on the spot. A non-issue that people talk about. And for me, it's people complaining that the language is not easy to understand. When they actually, like you say, spend a week looking at it, they can very quickly get to understand it. I think that it's possible to write really difficult to understand Rust, and that comes back perhaps to some of the metrics points that Jonas raised in his talk, that we need to be able to to look at software and say, is this code actually good? Is it nicely written? Not just does it do the right thing? So yeah, I think it's a non-issue. I think Rust is eminently understandable. I have far more difficulty with C, but a lot of people complain about it until they actually do it.
A complete non-issue is that the compiler is actually tough for the engineer who writes the code. It complains a lot about a lot of things. You have to live with it. It's like, and it's a non-issue because exactly it does the work it should do.
Absolutely, almost the point I would have raised, and that is the steep learning curve that Rust is supposed to, or is said to have. You're just getting one step closer to it compiles, it works, right? And yes, you have to read compiler diagnostics more carefully, and maybe we not have like sufficient amount of Rust developers yet. And then if you have a steep learning curve, this might take too long. However, if I look into our company, there's many colleagues who are really eager on developing in Rust in the future.
I have a question about the steep learning curve, because this is definitely a meme that Rust has had since about forever. And my problem, to be quite honest, is like I learned Rust pre 1.0, where it was actually changing daily. Like quite literally. So I have actually no good intuition about the learning curve. Is that getting better, or is that staying about the same nowadays from your impression?
I started using Rust like 6 years ago, but what I still sometimes struggle with is, of course, borrow checker, because you don't get where you lost track of, your brain lost track of the ownership. And sometimes it's like, in the meantime, I know some of the patterns I can use to, for instance, modify something I'm iterating over. Mm-hmm. But that is something I think you still need to get used to.
Bad engineers will have difficulties. I can give you a concrete example. When we started to have our tool work on Rust code, we had to have all our analyst team, our service team train, because they were doing analysis on C and C++ code, and they had to rely on Rust to be able to analyze Rust code. They went through the tutorial. So if you have someone who wants to discover what Rust does, tell them to do the tutorial, but do it seriously. And after that, of course, you're not an expert, but you can practice. And that's something actually you don't find in many programming languages, and the Rust tutorial is really, really good.
So at Codethink, we do very basic introduction to Rust courses. That's like 6 hours of content. And I've generally found that the less experienced a programmer is when they start that course, the more likely they are to finish it and do well. So I think the steep learning curve is an impression that has been built from otherwise experienced software engineers who think they know better than the compiler and therefore are very angry with it all the time when it's telling them they're wrong.
Interesting. There's actually a paper around that. I'll send that around at some point about learning programming languages is a learning process like everything else, and one of the biggest problems is what's called interference. Your old knowledge struggles with the new. That can be addressed, and it's no different than any other learning process. But that's interesting to see that as a practical observation.
Well, I think also learning a programming language in terms of the modeling in your head is very similar to learning a spoken language. And the older you get, and therefore nominally the more experienced you probably are in your field, the harder it is to consume new natural languages, and therefore possibly new programming languages as well.
Interesting observation. Thank you. With that, I'd actually like to open it up. Are there questions in the room? Is there anything people would like to talk about, hear the panel talk about?
So some of your answers, I don't remember exactly which of you, led me to a thought, and I wonder what you think about it in terms of quality and qualifications of the software in the open field as well. Would it make sense for Crates.io to kind of become aware what projects potentially are qualified, or follow the trusted software framework, that you could actually do a kind of a search based on that, or even run a check with cargo deny or something like that for somebody who would be really interested in that trustworthiness? Does it make sense or not?
Okay, I'd like to start with that. I don't think that makes sense for several reasons. We've seen that multiple times, that if someone uses existing open source software, like qualifies it, makes changes on it, in many cases the open source project is not interested in taking back that changes, right? Because they are interested in performance, not in robustness. So you have a conflict of goals there. On the other hand, Crates.io is not, you don't have a contract with Crates.io, right? And safety is very lot of who takes responsibility. For that, you need contacts, and you have this kind of contract only with a party that actually qualifies this code for you. So having such kind of indicator on quality, like you might get from a trusted software framework, fine, but I don't think this will help for any kind of work you do in the safety domain.
All right. there's one part of the definition of safety that we missed at the beginning, I guess, which is that when you pursue a safety certification, you also have someone who says your code or your software or your system is of quality good enough and indeed does what you're doing. The key word is exactly what he said, it's responsibility or liability, ultimately. And so the question is, would a declaration or a verification of the quality of the software in Crates.io actually help in having someone responsible for it? I'm not sure. Yeah. Right. So that's where I was really interested in the presentation yesterday about from the Eclipse project, to be able to exactly demonstrate the level of maturity and how confident you can be about a piece of software, because I think that helps tremendously. That pushes something in the right direction.
And yeah, so I think that obviously with my Eclipse TSF hat on, I would love it if everybody who published a crate was following the TSF and could publish their trustable evidence and score. But I think that for Crates.io, it's a difficult thing for it to be expected to manage that data, but perhaps it could aggregate data from other organizations or other data sources. So for example, it could say, has this version of this crate had a security analysis done on it? Can I link to the result of that? That kind of information, I think, is valuable because it helps to make a decision about, do I want to take this dependency? But it does not help with the responsibility subsequently of the fact that you have taken that responsibility. That still has to vest with the entity that's trying to get that certification.
And then you'd ask a lot from people who are actually doing this, in most cases, in their spare time, right? Why would they? Like, safety is the point of something commercial, right? You're only interested into safety if you're doing commercial products that you sell to someone. And that is completely on the contrary to people building software in their spare time.
Can I ask who here is aware of things like the OpenSSF scorecards? A good few of you, right. So imagine that there was something along that lines that was published on Crates.io. Would that help you to select between dependencies? Possibly. Would it give you a guarantee that that project was good? No.
Stephen, I got the message on the screen. I have a question over here.
Yeah, more a remark, because I found it really interesting is the discussion now about, let's say, open source projects, people which are doing this in their spare time, for instance. And then I really like the example of curl, for instance, which is used in safety critical projects, but none of them is even, let's say, even the automakers are not, or car makers which are using the software, has even the intent to give some money to the people and the developers, and they really would, let's say, benefit a lot from this. So therefore, building a bridge here where, for instance, let's assume Vektor would use some kind of open source software and would really benefit from it, and maybe it's a student which has created a crate, and most of the time, as I realize it as on myself, for my own, let's say, or open source projects, when someone else is using it, it's really something rewarding. It's really say, okay, cool, it's now running in a car, and I would be open to, let's say, support the company or whoever has an interest in creating some safety artifacts. It can also be closed source, but this would be a nice loop back to finance also open source projects. But this is something which I barely encounter, and it's always like something like, yeah, there is a conflict of interest, or not a conflict of interest, but let's say different interests. This is, let's say, the open source developer has no interest in safety critical stuff in the end. But I think this is not true. It's more like a different mindset that companies often think, okay, it's for free, and when it's not there for free, then I have to redo it on my own, for instance, and that this circling back to really provide something for them is hardly there.
Yeah, so I've heard presentations from companies you should be aware of. They tried giving back what they changed because like they found bugs. Of course, they were happily accepted by the open source project. They found missing features that the project actually thought were implemented. And then they introduced a lot of checks for robustness. And the project said, no, we don't want that. We don't upstream that anymore.
You are right. This is a problem.
And I've heard that multiple times, actually.
Yeah, but here also you have the counter side for this. For instance, when you introduce this to an open source project, which is, let's say, done in the spare time, with new features, comes new overhead, which you have to maintain, you have to document, for instance. And then again, the incentive for this is sometimes like you get a big pull request, bring this into your project. Now it's up to you to maintain this, for instance. And what the expectation, like for the one who gets the pull request, seems like it's like, okay, it's now off my guards and now you have to maintain it and I get, let's say, maintenance for free. And this is something, a mindset we have to change, for instance. And this would actually benefit also safety critical systems if you could, let's say, build a bridge between people which are doing open source for fun and free, and we use the software which really benefits us all, and we say just connect to these people, create something for them so that they also are open to create safety critical artifacts, better test suites, and they are most of the times happy if they just see what kind of benefits other products, or let's see what other products gain from them. So therefore, I think this is really something which is missing in the open source software industry.
Any feedback on that? Oh, Daniel.
I just wanted to reinforce that with my open source hat on, that when you all work with projects and you go, oh, here's a patch that adds a new feature or something, you're not giving a gift to that project. You're giving a millstone to that project. Perhaps be around to help them carry it for a little bit. Get involved, assist the community as well as benefit from it.
Maybe I want to say something to both of these feedbacks as someone who's been operating, like I've been responsible for parts of Crates.io for a while. One of the problems that is definitely present in a lot of major projects, and the Rust project is no exception, is there's also a tendency that people want to have their approach blessed in a way. Particularly on that question on could we use like some kind of format for indicating quality of projects. That will lead to a huge discussion with a lot of vendors that want their quality metrics to be the one on Crates.io. And this is something that also for good thing the Rust project is very aware of. But that means if someone wants to do this, that's a project for the next 5 years and not for the next 2 years.
Yeah. One point that's interesting is going back to the question of what are we missing in Rust. One thing that's currently cumbersome or hard to do is to not do open source. There are business practices where you can actually ship pre-built stuff to your customers. And in Rust, the general approach is that you have to provide all the sources there. Or if you don't, then you actually lose some of the power of Rust to actually give you extra information. I don't know if that's something that should change. I'm just pointing it out.
This is actually where I have a question. Is safety also a certain sector of the industry which is its own rules and culture? And I sometimes have the impression it's like there's an amount of, well, this is how we do it in our segment of the industry, and we ship things as binary and we link them together. And is there a change happening? Is like, or
I mean, we as Vektor have shipped software always as source code. So we've never built binaries. There are others doing exactly the opposite. I have not seen that kind of change, shift, whatever. So we are happy with like providing source code to our customers because that allows easier integration, faster round trips, and so on. Easier debugging if you need to understand what's actually happening. And I think we'd like to keep it that way.
Obviously, I tend to deal with larger systems rather than sort of microcontroller, microprocessor systems, and we often have to deal with taking on board binary deliveries. There are companies that, their IP is their IP, and that that they will not give that to us. But we tend to get it in process boundaries rather than source versus, things that you want to compile in, or maybe it's a shared object with a defined API. So one thing that might help there, and this is again probably a 5-year, not a 2-year question, is if enough of an ABI could be locked down that a .a and a .rlib can be delivered as a component that can then be used as a dependency through cargo. That could be a really powerful way to get more Rust into places where people are perhaps a little bit more protective of their IP.
No, I got your point in terms of yes, you have to, like with Rust, since there's no stable API for the Rust part, right? You need to have sources available, unless you can make it to have a complete executable binary. Then again, right? So it's getting more binary. What kind of options you have in with respect to what you could do in the C world today.
I think there's an evolution in the industry as well. I mean, if you look at where the practice is 20 years ago, it was very, very common that people would give you device drivers, operating system, everything in closed source. Now, it's not that the source is a commodity. It's more than the value in choosing a piece of software and a partner to work with is the support and the liability. And again, that goes back to the safety topic. It's not so much the code that you use as much as how well it was tested, how well it was developed, how well it was tested, and who takes responsibility. And those are the key aspects. And then the source itself, well, I mean, in some very corner case, obscurity is useful. In the majority, it's not.
Other questions from back here? Come back. Christian has another one, but I'm coming back here this time.
The question about which supposed problems are actually non-issues in practice reminded me of the existence of unsafe, because sometimes that's seen as a sort of fatal gotcha for the Rust haters to hate on Rust. How much would you say is the existence of unsafe and dealing with unsafe code a concern when reasoning about safety critical systems?
Not at all. I was just laughing because we had that point yesterday. We discussed that yesterday. If you do embedded systems, you need unsafe, right? You can't write to a hardware register without unsafe. I don't think this is an issue at all, because whatever you do in Rust, it's typically a lot of times better than the same thing you would do in C. Because with unsafe, you explicitly marked the places where to look at. And yes, you need some kind of rules or special review on the unsafe parts. But it's actually the same you would need to do for the whole C software you had, right? So it's just getting better. And you need it, and this is really a non-issue. Thank you. We missed that.
Yeah, I just want to re-echo that anyone who says unsafe is a fatal flaw in Rust obviously never writes any code ever, because any other language is going to bite them.
So the issue of incompetent engineers is much bigger than unsafe.
What might be an issue with unsafe is that sometimes it's used in places where it's just not necessary. Right. So I remember for Actix, there was long discussion on, there were some places I've never followed too deep into that story, but I just read some posts that saying, yeah, a lot of people were unhappy with the usage of unsafe there. Because they said it's just not necessary for performance reasons, whatever. You could do the same thing in the safe subset of Rust. But the point here is that, and that's something we did, is install a small team where you have to go through with all your unsafe code, just to prevent this kind of overusage of unsafe. And that's quite simple to do so.
Okay.
The reason why I was pulling a face is because back when the active discussions were happening, I was one of the leads of the community team. And one of the big problems was if anyone takes an ethical stance of, hey, you shouldn't use unsafe or you should use unsafe, which happened in that discussion a lot. I find that problematic. It's like, as you say, like there's an engineering decision whether to use unsafe or not, and there's ways in how to review it and figuring out if that usage is okay, and particularly if that implements the right thing.
I will claim that, and it's probably true, but I will claim that using a completely unsafe application in Rust is still a generation better than what you would do in C, even if it's completely unsafe.
Okay. Then I have, well, a little bit, we had this talk, conversation here a little bit in the hiding. So open source safety is something that I hear a lot in the recent years. What's your take on that topic? Is it just a North Star, or is it actually something that is becoming an established practice in the recent years?
Do you mean open source projects taking safety seriously, or do you mean people who are doing safety related projects consuming more open source?
Yes. It's a vague term.
Thank you.
I've deliberately phrased the question vague because I feel also a little bit, it's a term like, I always joke, like if I'm at an automotive conference, all talks start with a 15-minute definition of what the speaker thinks software-defined vehicle is. And are we in that phase?
So I don't think we're in that phase. To speak of it from the open source maintainer perspective for a moment, I think that a lot of the things that safety concerns itself with, particularly around process, are things that actually a lot of projects already care about. So formalizing that a little bit, coming up with a way to represent that, and having open source projects effectively grade themselves against that by choice is something that is growing. So the OpenSSF did a really big thing with the scorecards, and I think that there's a possibility that the TSF could be used as a way for projects to start grading themselves in a number of these aspects. That's not to say that they're necessarily going to care about everything that safety people care about, because they're just noodling away in their bedrooms at night having fun. But at least they can noodle away with good CI, and they can understand where their dependencies have come from, and they can keep control of this stuff and publish lock files and so on and so forth. From a using open source in safety perspective, I think there are two sides to this. One is on the tooling side, which I think more and more companies are doing without realizing it, particularly when they're running, let's say, they're using an internal GitLab as their source code control system. That's primarily open source. So they're already caring about that, and they're probably making claims about their process that's being enforced by that open source software that had no safety certification happening to it. So there's an increasing use of open source in potentially hidden places, but then consuming open source into safety chains, I think, is something that we are still working on as an industry. Something that my employer is working on, trying to get that whole Linux all the way through. But I don't think it's something that anyone who's already got, let's say, a Linux-based system through certification has actually fully worked out. You know, a lot of the claims that I'm seeing around it, I don't think hold water, but apparently safety certifying people think hold water. So it's going to be quite an interesting few years as potentially more problems come to light that weren't considered before, and how we overcome that.
Yeah, so I think we need to distinguish here, because as you always said, safety is about responsibility, liability. So the random person in Nebraska will not take liability, right? And if you look into all the open source licenses, everyone waives liability. There are, or there may be, open source projects backed by companies that you could, or that could be used maybe in safety projects. But still, from a safety point of view, you would need to show that actually the people working on it were skilled enough that they knew what they were doing, which is very difficult if this is just an open source project. And this is actually, to me, a completely unsolved problem. The next thing is if you need changes, features, whatever, and this is also part of the safety, that you have a plan, a schedule, basically, that you have planned to finish all your safety activities, like testing, reviews, and so on, and it can ensure you've finished before you need to start production. again, this is something I can hardly imagine for open source projects, right? Because you don't have a contract with those projects, and that is actually something that is foreseen in all safety standards, that you have this kind of contractual relationship, that you have some kind of power to exercise, that this is actually happening. And the only thing you can do then as a company is saying, yeah, okay, I'll take that. And in doubt, I'll do all on my own. And this is some kind of high risk, actually. And that is something why I think I don't have indicators that this is actually changing.
Just a side thought. There's not safe and not safe. There's actually a spectrum where if we look at, well, I don't know if, well, okay, two comments. One is I've seen closed source projects that are safety certified that are led in a way much, much worse than many open source projects. That's very clear. The other thing is the most critical pieces of the software that people will use in the mission critical system, I very rarely see open source pieces in them. However, for everything that's medium critical or non-critical in the same system, then open source is not even in question anymore. Of course they use it. Then they will look at it and they will verify it in enough so that it can be used in there. And again, the fact that the open source projects majoritarily are organized in a virtuous way pushes everything in the right direction. So there's hope, but we're not there yet.
I think one final thing on that is that one of the really nice things about software that's being made in the open, that's being made visibly and all of the processes are visible, is that it is possible for you to measure that despite not being in control of the project. And even though, yes, some aspects of these standards and processes talk about having control, if you can measure and demonstrate that things were done effectively in as good a way as you would have, then your ability to patch on top of that can be potentially sufficient to mitigate.
It's interesting, but particularly one thing I just wanted to observe is there's also a change currently in a lot of open source projects where they're thinking deeper about their policies. For example, I know a lot of open source projects nowadays that don't take contribution because they're saying we're only working with the people that we know, which is precisely what you say about like control, like what is the quality of our engineers? That's a very similar thinking. So is it, as like a final question, should we stop about talking about both of these terms in these vague senses, or like safety in open source is like what kind of open source and what kind of safety?
I understand there's kind of taking contributions only from known people. I read this morning again about like supply chain attacks on various open source projects. To me, that far better matched in that area, in that security area, supply chain attack area, than in the safety thing. Because again, you don't have a party that is actually keeping that kind of records for a long time, and that is something you would need to do if you take it seriously and take really liability from it. So I don't think this has anything to do with it. I don't say that open source and safety do not go together, but I have not seen anything or a business case in many cases that allows you to open source your project and make money with it in the safety domain.
I was just going to say that whether or not an open source project is saying we're only going to take the people we trust, you still have to decide if you trust them. And so the same mechanisms that you would be doing to assess a project and say, okay, yep, the 5 people that they're prepared to accept changes from, I think will make good changes. You can do the same assessment for the 200 PRs that they've accepted from random people as well. It just might be more work, and so perhaps more automation is going to be necessary to enable that kind of thing to be more comfortable for people.
Not much to add to what you were saying. I mean, ultimately, the fact that you're taking responsibility means you control what you're taking. You have always the good thing with open source, you have the choice not to use it too, which is also a freedom given. You take the risk, you measure the risk, and then you use it or you don't use it. What's important is again to be able to assess it, and that's where the industry moves forward.
Well done. Thank you all. Thanks for the conversation, and we'll go into lunch.